This is for Year 12 Specialists. It's the 2015 SAC 1 Work Solutions Continued. So we're up to 1C. In 1C, I've got to find the angle between A and B, find the exact angle. Now I know from the previous part of the question that this is A, this is B, that's the magnitude of A, that's the magnitude of B, and that's what A dot B is, just by looking at the previous working out. Okay, so if I'm looking for C part 1, I've got A dot B will equal the magnitude of A times the magnitude of B times the cos of the angle, and that's what I'm looking for, which means the cos of the angle will equal A dot B divided by the magnitude of A divided by the magnitude of B, which will be minus 15 on top of 3 times 5 root 2, which will be minus 15, 5 goes into that, 1 goes into that, 3 goes, so it's 1 on root 2, negative, which is root 2 on 2, negative, is that answer. Since all stations to Collingwood, these are the two quadrants that the cosine is negative. Since I'm looking at the angle between two vectors, I would take this, the smaller, as being the answer, therefore quadrant 2. And that answer is actually going to be 3 pi on 4, since root 2 on 2 is my pi on 4 answer. Hence, find the exact value of tan. Well, in that quadrant, tan is going to be positive. No, it's going to be negative. So the tan of 3 pi on 4 is going to equal negative 1. That's the answer to C part 1 and C part 2. In D, use the result of C part 1. Well, I know that the angle is 3 pi on 4. That's my result from C part 1. And the cosine of that angle is negative root 2 on 2. So find the magnitude of vector C. Magnitude of vector C is the scalar. Therefore, I've got a triangle, and I'm trying to find C. So I'm going to use the sine rule, which says C squared equals A squared plus B squared minus 2AB cos of the angle theta. So I've got C squared is the magnitude of 3 squared plus the magnitude of 5 root 2 squared minus 2 times 3 times 5 root 2 times negative root 2 on 2. 9 plus 50 minus the 2's cancel. Root 2 times root 2 is negative 2. 10 minus 30 is going to equal, so that's plus 30. 89 is going to be C squared. C is the square root of 89, is my answer to the magnitude of vector C. Okay, part E. Find a vector D in terms of this form that is perpendicular both A and B, remembering that A is equal to this and B is equal to that. Okay, if D is perpendicular, therefore A dot D equals 0, and B dot D equals 0. So I'm going to call D equal to A in the I plus B in the J. I won't use, well, it's already been, okay, so that is D. It's been defined for me. So therefore, I plus 2J minus 2K dot A in the I plus B in the J plus C in the K has to equal 0. So A plus 2B minus 2C equals 0 is equation number 1. And B dot D equals 0, therefore 3A minus 4B plus 5c also equals 0. And that's equation number 2. Now I'm going to solve them simultaneously. So if I times this one by 3, negative, I get minus 3a minus 6b plus 6c equals 0. And I've added to this one 3a minus 4b plus 5c equals 0. I get minus 10b plus 10c equals 0, which means that 10b equals 10c, b equals 11c, 11c on 10. Using equation number 1, a plus, replace b with 2 lots of 11c on 10 minus 2c equals 0. Therefore, a plus 11c on 5 minus, that's minus there, 10c on 5 equals 0. A plus 1c on 5 equals 0. A equals negative c on 5. Therefore, I can say that my expression a in the I plus b in the j plus c in the k equals a in the I, a is minus c on 5 in the I plus b, and b is the same as 11c on 10 plus 11c on 10 in the j plus c in the k. Therefore, expression for D is C minus 1/5 in the I plus 11/10 in the J plus K. Or if I take a minus C on 5 out, I get I minus. So if I take out the C, then I take out the negative 1/5, then I take out the negative 2. This, and there are lots and lots and lots of examples for D. One could be 2i minus 11j minus 10k. Another one could be I minus 11 on 2j minus 5k. If I double by negative 2, I get minus 2i plus 11j plus 10k. All of them are examples for D that have them perpendicular to both A and B.